Hi, I'm Steve Levin, and I'm an astrophysicist at NASA's Jet Propulsion Laboratory. Today, you're going to be helping me and some other scientists look for intelligent extraterrestrial life by finding possible signals from them in our radio data. To get started, let me give you a quick introduction on how we do that. So, let's begin with the acronym you'll be seeing a lot, SETI. SETI stands for Search for Extraterrestrial Intelligence. That means we're looking for intelligent life in outer space. Looking for extraterrestrial intelligence is a hard problem because we don't know what to look for, we don't know when to look for it, and we don't know where to look. So to begin with this difficult task, we'll need to make some guesses and assumptions. We start with a very big assumption. Someone deliberately sent signals to Earth and they want us to find them. Signals intended for someone else might be a lot more common, but they're also likely to be a lot weaker as seen from Earth, and so eavesdropping on accidental or leakage signals is probably too hard for us. So where do we look for these signals? Rather than trying to guess which are the best stars to observe, we try to observe a very large number of stars. Suppose we imagine that every star has planets and that every planetary system contains a planet hospitable to life, and that every hospitable planet develops not just life, but intelligent life, and that the time for the intelligent life to develop is only 1 billion years compared to the 4.5 billion it took for us. Now suppose that a typical civilization produces radio signals for 1,000 years, and that all of them aim a detectable signal at Earth before they die out or move on to some other technology. Our chances of looking at the right time to catch that radio signal are only 1,000 out of 1 billion, or a 1 in a million chance of catching a radio signal when they're broadcasting it. Fortunately, there are 100 billion stars in our galaxy, mostly concentrated in the galactic plane. So now that you know where we look, let's talk about how we look for intelligent life with radio signals. We scan the sky for radio signals because out of all the other wavelengths in the electromagnetic spectrum, radio waves use the least amount of energy, which makes them the easiest way for any intelligent extraterrestrials to send signals through outer space. We're using the telescopes like a radio in your car, searching the entire galactic plane, scanning the telescope one small patch of the galaxy at a time, trying to find a radio station that's not broadcasting static. Since we don't know the right frequency to look for, we cover as many frequency channels as we can. We measure the signal strength in 134 million different frequency channels all at once, every 2/3 of a second. That's a lot of information to process, so the computer only records the channels with the most power in them and puts it into a big data file. And that's where you come in. In that big data file that the computer creates, there's still a lot of static, just like there's a lot of static on the radio in your car. The static in space can come from galaxies, quasars, and pulsars that naturally produce radio signals. But for us, most of the noise comes from the receiver itself, just the way a radio produces static when it's not tuned to a channel. Another difficulty is radio frequency interference, or RFI. RFI can be from radio signals produced by stuff like microwave ovens, cell phones, passing airplanes. A computer has a tough time sorting out the difference between real candidate signals, noise, and RFI. So your job is to look for a real signal hiding amidst all that noise and interference. A real signal is a narrow band radio signal. These signals are restricted to a very small frequency range, just like your favorite radio station. Natural radio signals aren't restricted to a certain frequency range, so finding one almost definitely means that intelligent life sent it. You'll be looking for this real signal in a waterfall plot that the computer makes with the data, displaying frequency on the horizontal axis, time on the vertical axis, and using color to show the power in each channel. By looking at the data, adjusting the plot to zoom in or out and pick out the areas you want to study, you'll make a list of channels and times to mask out or ignore, and a list of candidate signals to reobserve. A candidate which shows up a second time deserves special attention with repeated observations to see whether it's a real signal, RFI, or just a coincidence of noise. We'll have to sort through a lot of noise and interference looking for that real sign of extraterrestrial intelligence. But if we do find evidence for intelligent life elsewhere in the universe, it could be the most important discovery in all of human civilization. We won't know if there's life out there until we look for it, and today you could be the person who makes that discovery. Thanks for helping, and good luck on your search.